In this question, we have a particle that starts from not the origin, but 10 meters from the origin. So let's say if I have a scale of x, so this is my position, it starts at 10 meters, wherever this is, and it starts moving. And it goes with the velocity shown in this graph right over here. The first part of the question is asking you if this particle has a turning point. What does that mean? That means if the particle is just moving towards a specific direction and then kind of turn back and starts moving at the opposite direction. It says the direction of the velocity changes. When I look at this part of my velocity time graph, looking at this, from 0 to 1, it's in the negative side, so my velocity is negative, and from 1 to 4 is a positive velocity. So what does it mean to have a positive velocity? It means that it's going in just a positive direction, and if it's a negative, it would be a negative direction. Right? Therefore, I'm going towards a negative direction here in the first part, and then on the second part, my velocity is positive. That means that the sign of my velocity is changing from negative to positive. Therefore, I have a turning point right here at 1 second. So yes, at t equals 1 second. That's when I'm turning back. So from 0 to 1, I had a negative 4 meters per second. So I started from negative 4 meters per second as my velocity at time equals 0. Now I'm moving to negative 3, negative 2, and finally until I reach 0 velocity at 1 second, right? So what's happening to my velocity? First of all, the negative only means that I'm going in the negative direction, right? So from 4 meters per second, I'm going to 3 meters per second, then 2 meters per second. So therefore, I'm slowing down, right? So I'm moving in the negative direction, but I am slowing down between 0 to 1. Now from 1 to 4, my velocity is increasing. So as you can see, it's going from 0 to 12 meters per second. Therefore, I'm increasing my velocity in the positive x direction. It means that I am actually speeding up. All right, now that I know this, I want to find out what the object's position is at t equals 2. So at t equals 2 seconds, 3 seconds, and 4 seconds. Now, in order to do this, what I know is that the area underneath the velocity time graph is the displacement. Right? Therefore, what I need to find out is that what area is covered underneath here. So if I had to find out what this area is, then I know how much I've actually traveled. Now, one thing that I know here is that from 0 to 1, at 0, I was at 10 meters. Now, at 1, I'm going back to 0 meters per second. And also, because I'm in the negative, I'm actually going back to what my original position was. So I moved everything around so we can actually see this graph a little bit better. Now, if I were to actually draw a corresponding position time graph, what I actually have here is that I'm going from 4 meters per second to 0. So I'm stopping at 1 and I'm kind of doing a turn back. So I have a turning point at that point. And what I know is that my velocity is negative and I'm also slowing down. So if the velocity time graph is a straight line with a slope, then my position time graph has to be a curved to actually represent that, because this basically is the derivative of my position time graph. So I'm going reverse. Now from negative 4 to 1 here, as I said, I'm slowing down, so I need a negative curve. And also my question mentions that I start at 10 meters, right? So my initial position at t equals 0 is 10 meters per second. So that is my first point. I'm just going to draw it right here. So now that I know I'm starting at 10 meters, what I want to find out is that the story of this. So what I'm doing is that I'm actually moving from, let's say, at 10 meters. So if I'm going back to my picture here, so what's happening, I'm starting at 10 meters. If this is the positive direction and this is the negative direction, I'm going to start moving this way towards the negative direction, and I'm going to be slowing down. Then once I get to this point, what will happen is that I'm going to start walking back, but I'm going to speed up and I'm just going to continue going, right? So I need a curve from 0 to 1 here that has a negative slope and also speeding up. So what kind of curve will give me that? So let's take a look at this kind of curve. Let's say if I had my two lines here and I had my instantaneous velocities at this point and this point, you can see that this one is less steep than this. So that means that I'm slowing down, and it's also a negative slope. These lines will have a negative slope, right? Because the second point is lower than the first one. Therefore, my line here is going to go like this. And at 1 second, because I'm going back to my original, which is 0, and my velocity is 0, is when I'm going to have the turning point. I show the turning point as something like this, because at this point, at this 0 point, my instantaneous velocity will be a horizontal line, and a horizontal line slope is just 0. Therefore, that's how I'm going to show it. And then from here on, it's just going to start growing and going up. Perfect. Now that I have a sketch of what my position time graph looks like, what I want to do is answer this question. So what is the position at 2 seconds, which is over here? So what's happening is that I want to actually look at the area. I don't really need to use this graph because it is a curve, and finding the area and things like that, it's just, I don't want to get into that on this video. So what I'm going to do is that I'm going to break this graph apart into these sections, and I'm going to calculate the area in each side. So let's call this area 1, area 2, 3, and 4. So for area 1, what I have is that it's a triangle, so it would be length times base divided by 2, so that would be the area 1. My length here is 1, which is 1 second. My base here is -4 over 2. So it would be just -2. Now for my area number 2, it would be the same thing. So it would be the length times base. So I have the 1 second. You see from here to here is 1 second. And then the base here. So I have 4 seconds on top there, divided by 2. So same number there. For area number 3, what I have is that I can actually break this part into a square and a triangle here. So I have two shapes. So for my area 3, I would have area 3A and area 3B added together. The side of the square is just 1 here and 4 here. So the area of this square would be 1 times 4. And for the triangle here, it would be the same triangle as we have at 1 and 2. So it would just be +2. As you can see, the base of the triangle here is 1 and height of it is 4. So 1 times 4 divided by 2, just like we did here, it's 2. So for area 3, I will just have 4 plus 2, which is 6. And for area 4, I can break that one apart into 1 square, 2 squares, and another triangle. So it would be the 2 squares that we had here. So it would be area 4 equals 2 of those squares plus 1 of the triangles. And that would be 8 plus 2, which is 10. Now, what would be the object's position at 2 seconds? So let's look at this. At 2 seconds, I'm going with a triangle 1 and triangle 2 added together. So it would be 2. I just got rid of everything here. So it would be 2 minus 2, which is 0. So basically the displacement is 0, and as we explained, it makes sense because I'm moving from 10 meters to 0 and going back to 10 meters, so that takes 2 seconds. Therefore, I've traveled back to my original position. Therefore, over here, at 2 seconds, I'm going to be at my position 0. So my x at 2 would be at 0 meters. Now for at 3 seconds, I'm gonna have the area of the first one, the second one, and the third one added together. So it would just give me 6. Therefore, x3 would be at 6 meters. Now at 4 seconds, the question asking, it would be all of them added together. So it would be 10 plus 6 plus 2 minus 2. It would just be 16 meters. So x4 would be 16 meters. There you go. If you have any questions, please post them down below. I know these questions could be a little confusing, so let me know if anything doesn't make sense, and I will go through that with you in comments, or I will make another video for you. Thank you so much.